Hey everyone, this is Joseph from dataengineering.com. In this video, I want to go over a DataOps workflow for a ELT pipeline using dbt. In order to automate the DataOps workflow, we will be using dbt Cloud and we will be using Snowflake as our data warehouse. As always, if you'd like to follow this along in the blog format, I'll leave the link in the description below. The blog contains the code as well. Let's get started. So what is DataOps? DataOps refers to managing different environments such as development environment, your staging environment, and your production or release environment, and also ensuring software engineering best practices such as CI on your data pipelines. So if you're already using dbt and if you're figuring out how you could test your transformation logic locally without having to push to staging or release, and how you could ensure that your transformation logic is correct as defined by your tests on production data before actually creating data models, and how you could automate these tests on these CI tests on pull requests, or how to grant appropriate permissions to Snowflake, then keep watching this video. We'll go over the entire process of setting up dbt Cloud, setting up Snowflake permissions for your dbt use, and also connecting your GitHub repository to dbt Cloud so that dbt Cloud can run CI on pull requests. Before we get started, you need to have a Snowflake account, a dbt account, a dbt Cloud account to be more specific, GitHub, and have Docker installed on your local machine. You'll also need to understand the basics of dbt. I already went over the basics in another video. I'll leave the link in the description below. So let's look at a high-level overview of what we are trying to do here. You can imagine having a developer developing locally on dbt. It's version controlled by Git. When you're developing locally, you're actually going to be developing against the dev schema so that your data models are not exposed to anyone else. When you put up a PR, dbt does a CI job which creates a PR specific schema and creates your data models there, runs your test there, and ensures that the test pass. If it doesn't pass, it just says fail on your PR. If it passes, you can merge your code in and your job will be ready to be run on production. The first step is setting up permissions on Snowflake. At a high level, this table represents the permissions that you need. So you have dbt Cloud and dbt Cloud Dev User, and this dbt Cloud Dev User could be like your specific name and then your colleague's name, etc. So each developer will have a specific user. And then you have roles. Roles are Snowflake's way of grouping together permissions. So dbt Cloud will be granted access to a transformer role, which will have read permissions on a raw schema within the prod database and read-write permissions to analytics schema within the prod database. And raw and analytics are basically the idea of separating incoming data, which will land in the raw data schema. So it could be data from CDC, it could be data from some events pipeline, it could be data from connectors such as Fivetran or Stitch. An analytics schema will be the schema that your end users use to query the data. And there's a concept of warehouse in Snowflake, which represents the machine or cluster of machines which is used to execute your query. And you can assign it different sizes like small or large or whatever size you want. So this script basically creates these roles and grants them the appropriate permissions. You could go with the script. I'll leave the link in the description below. It's in the blog. But at a very high level, you create a warehouse, you create a database, you create schemas in the database, and you create a role, grant the role usage and operation permissions on the database and schemas respectively, and then create a user and associate the user with that role. You do the same for dev environment. You could also imagine doing the same for a staging environment. So once this is done, you will need to log into Snowflake consoles using dbt Cloud and dbt Cloud Dev to change your password. And at the end, you will have 3 Snowflake users: your user, dbt Cloud, and dbt Cloud Dev. Now that we have all our permissions granted to Snowflake for dbt Cloud, the next step would be to get your local development environment working. So you could use this repository to download a scaffold that we'll be using for this project. Download this repository, cd into it, remove the git file, and initialize your own repository. You will also have to create a GitHub repository and link this Git repository to your repository on the cloud. This is essential for your dbt Cloud to work with this GitHub integration. So when you clone this Git repository, you'll have a profiles.yaml file, which is where you specify your connection parameters. So here you can see it's a development environment, hence name dev. It's a Snowflake connection, and you have to put in your Snowflake account ID here. Snowflake account ID is usually a number or alphanumeric string followed by a region and snowflakecomputing.com. So when you sign up for Snowflake, you will get this account ID as well. And username, we are using dbt Cloud, and fill in your password here. Transformer, dev role, development database, transforming warehouse. Again, you can just type in your username here. The idea is that the schema is unique per developer, so your models don't get overwritten. Threads represents the number of processes that will concurrently be executed on your warehouse. And this one is a Snowflake specific parameter that you can set to true or false. If set to false, the connection will close after, I think, 4 hours. So once you have all that set up, your folder should look something like this, where you'll have, where you have some basic models. They come with the dbt init scaffold and your profiles.yaml. Remember to fill up profiles.yaml with your parameters or variables. So once you have that set up, we can run dbt commands via a Docker container from Fishdown Analytics, create as of dbt. What you're saying is take the current working directory or path of working directory and mount it on user app location within the container, and do the same but mount it also on .dbt folder in the container. And this is the folder where dbt will look by default for your profiles.yaml file. So we are making sure the profiles.yaml file, which is present in the current working directory, is also present within the containers dbt profile default location. So let's go ahead and run this. Here. If you don't have Docker, it'll be something like it'll just be dbt run. But because we have a Docker container, we have to input these commands in front of it. So you can see your first model was created and your second model was created. So you can see how it's created in dbt jkm. That's my name, so I just use that schema and my first dbt model. Similarly, my second dbt model. You can see that here. So here we are logged in as dbt Cloud Dev, and this is the Snowflake UI. You can see in the dev database, both your models have been created. So you can see how multiple engineers working simultaneously will have their own schema in development, and by virtue of that, they will not overwrite each other's data. That's what's shown here. And because this is a Docker container, you can run other commands like testing, generating documents, and serving documents as a web server, etc. So any dbt command you can think of, you can run here. You could basically replace this with dbt, and whatever commands are possible, they could be run from here. So we run a test, and it runs through some basic tests, which all pass. Now that we have a local environment set up and working, the next step is to set up a dbt Cloud account. So sign up for a free dbt Cloud account, and once you log in, you'll be prompted here. So let's go ahead and set up a new project. Click on this begin, let's ask for a name. Let's call it DBT development. That should be fine for now. Let's choose Snowflake as our warehouse. And account. I set up my account ID, development role, development database, warehouse for development, development username, and development password. And I set up dbtjkm as the default schema for developing. So you could actually develop in DBT Cloud via an online IDE, web-based IDE. In that case, these parameters will be used. Let's go ahead and test the connection. Click on it, takes a few seconds. Right, so it succeeded. The next step would be to connect to a repository. So DBT has options to host a repository. So it's a call to manage repository. You could give it a Git URL or connect to it via a GitHub app. We are going to use the GitHub app because enabling the GitHub app will allow us to run CI jobs on pull requests in the connected repository. So let's go ahead and connect it. I'm already connected to it, but if you are not, it'll ask for permissions, and if you own your repository, it should be pretty straightforward to grant permissions. Go ahead and choose this. Takes a few seconds to set up. You could also import repositories from Bitbucket as well. Okay, so now your repository has been imported. That's great. Says we don't have any users. Let's skip. Okay, so this is the project page, and you can immediately start developing. What this will do is it will open your IDE, where you can look at your models, look at the compile SQL, run some queries to check results, run DBT commands, make a branch and put up a pull request. Essentially anything you can do, we were doing on our local environment, you can do it through DBT development environment. Right, we're gonna go into that right now because we just saw how to do that locally via code. You can do that same thing here. First thing we are going to do is create a deployment environment. So you have a development environment which is like dev, and then you have a deployment environment which is like production. You could also add more environments like staging or user acceptance environment as needed, but for this demo we are only going to be having a development and a production or deployment environment. So you see you have a development environment already, so let's create a new one called production, and let's make this deployment, and it's 19. So this is relatively important because the default branch DBT Cloud looks for is called master, but there was a recent change sometime last year in GitHub where all the master branches in new repositories are called main. So we'll use main, and we need to fill in our deployment credentials, which is DBT Cloud Dev, and the password. Let's save that. Oh, what's happening here? We have to grant it a schema. Is that one? Let's call it dbt jkm because that's the default schema. Let's save that. Something is wrong. Okay. Okay, it was saved. I just had to refresh it. So now you have a production environment and a development environment. You can also get to the list of environments pressing this hamburger menu and going to environments. One thing you have to do, especially if you are using a new repository, is go to development environment and change this custom branch to main branch, because in GitHub it's called main, not master. Now that we have both the environments set up, we could go ahead and create our first job. Click on this hamburger icon, click on jobs, create new job. So this job is going to be called a CI job, which is a job that is run for each pull request on the specified repository for the specified branch. So let's call it a CI job. This is going to be the production environment. Inheriting from production. One thread, target name should be default here. dbt run. Switch off the schedule because we don't want this running on a schedule. We only want this running on pull request. So click on check this, and it's already checked that this will only run on pull requests on the main branch. So let's look at this. It looks good. Let's go ahead and save it. So now we have a CI job ready for when someone puts up a PR. Let's try putting up a PR. Let's check out using a simple test branch. Alright, let's modify this my first DBT model and add these two lines naively. So model. So let's go ahead and add it. This does not make any sense. It just is a simple example. We are just adding to a ID. Okay. Right, so now we can add that. We can put up a commit message, and we are pushing it to our test branch on GitHub. Okay, so now go to GitHub repository, and this will be our profile, and it'll be called DBT development or whatever you want it called. Let's compare and do a pull request. Let's say simple model change to check CI run. Click create pull request. Give it like 2 seconds. What it'll do is it'll trigger a CI job here, which will run against your production data to ensure that your data models and their tests pass against production data. So we'll take a look. So okay, now you can see the DBT Cloud job is running. If you go to jobs and click on CI, you will see a job is queued, and you can see it's the under the default branch. You can see DBT Cloud PR something. So what you could do is, if you look at the production database, you will actually see a PR based schema. So what this actually does is it uses your production data but writes the output to a PR specific schema. This enables us to be confident when we are pushing our code to production, because the CI will tell us if tests on these model pass or fail. So if we go back to DBT Cloud, still running, and it failed. So it failed because I'm trying to run against the development schema using production credentials. What this will do is this will block our merge if you configured it. You could imagine if it doesn't block, you can go ahead and merge a pull request, and by this you can be very certain that your pull requests and the models that you are going to create in your production database is not going to be affecting your is going to be accurate, and it's not going to error out in production. That's how you do a CI. The next step is scheduling a job. So very similar. You go to jobs and you create a new job, and instead of running it on webhooks, you can specify any cron based schedule here, or every day or specific days of the week patterns as well. Once you set that up, DBT Cloud will take care of running that for you. Now that we have both our development and production environment set up, the next step is to create a CI job. A CI job is a job or a check that is run for each pull request that you make on your repository. So let's create the job first. Let's call it a CI job. We are going to run this job on production database. We're going to do dbt run. We will also need to do dbt test because we want to ensure that our runs run accurately and create the models, and we also want to run tests on these models. And we do not want these to run on schedule, so we uncheck it, and we go to webhooks and check run on pull requests. So this will ensure that this job gets run on pull requests, and this will ensure that it gets run on pull requests only on the main branch and not other branches. So let's go ahead and save that. In our local environment, let's go ahead and clear this up. Let's go to get, it's called main. So let's check out a simple test branch, and let's call it simple test branch 3 because I have the other two locally. Let's modify my first DBT model, just a naive change, nothing of importance. So let's go ahead here and say it's just a simple example to check how these CI jobs run. So add it and commit it. Simple change. Okay, and the next one is we push it to origin. Okay, so what this does is it pushes the branch to our repository, which is in GitHub, which we connected earlier. So if you go to GitHub, you will see a prompt to create pull request. So let's go ahead and create a pull request. Simple model change, create the pull request. So what this will do is this will trigger a DBT Cloud CI job. It takes a few seconds. You could also configure GitHub to block these merge, the green merge button until these DBT checks have run. I haven't configured it. It's pretty simple configuration if you go to settings and see protected branches. So let's give this a few seconds to get triggered. Alright, it looks like the DBT check is being triggered. So if you go to your DBT Cloud and click on the CI job, you will see a job is queued. An important thing to note here is this default branch DBT Cloud PR some number. This is important because it creates, or each CI run per pull request creates a unique schema in your production database. What this does is it uses data from your production databases and writes the output or the data model that you're creating in this PR specific schema and runs tests against this PR specific schema. This enables us to actually test the data transformations and run our tests against production data without actually creating production assets. Because in DBT you create production models and then you test against them. If you do that in production and if your tests fail, the end users already have access to failed data or incorrect data. So what we do is we do these runs and tests on a PR specific schema. So if you go to the production database, do a refresh, you see the PR specific schema having your tables and views. And you can see in this run that we also ran tests against these models. So that's how you ensure that your transformations are running accurately, not only on your development database, but also on your production data. So now we have a lot of our DevOps workflow defined. We have a local development environment set up. We also have CI set up to run on production environment to ensure that our data models are accurate. The next step is actually scheduling a job. So let's see how we can do that. Very similar to the CI job we created. We go to jobs. Let's say we create a new job. Let's call this full run because we are going to recreate all the models. It's not really a good practice, but for simplicity of this example, it should do fine. Let's go to production. Let's click on generate documents and we'll just be running dbt run. Let's do a custom cron schedule. Let's do it set it to run every day at 12 a.m. and it's run on the end custom branch. Everything else is accurate. So just runs a full run. A DBT run will recreate all your models. In actual use cases, you might want to separate your DBT runs for different models with different schedules, etc., depending on your use case. So let's save this. This will run every day, and it's set to run in the next 1 hour. But I don't want to wait, so I'm just gonna click run now. So this triggers a full run. And this will be run against production database because we chose the environment as production. Let's wait for that to complete. In the meantime, let's look at what documentation is. So one of the key values that DBT Cloud provides is hosted documentation. So when you run a job, you get documentation, which you have to define along with your schema definition in DBT. Project, and you can host this online and allow users to view documentation. So what this essentially does is it puts documentation as part of your repository, enabling easier maintenance of documentation, and you can have custom rules on your repositories. Let's wait for this job to be complete. Okay, it's running. So let's see how to create the documentation in the meantime. So we had checked create documents on that job. So what we could do is go to DBT Cloud, let's go to our account settings, let's go to projects, click on this, and artifacts. So click on edit, and for documentation we do it on the full run and we save it. So let's wait for the full run job to complete. Okay, it has successfully completed, which means in production you have your models created in the analytics schema. You can see it was just created now. So now you can look at the documentation. You can click on this hamburger icon and click on documentation. It opens up a new window where you can see your models, how they were created, what is the model lineage, and such. So give it a few seconds. Alright, so this is a very naive model. Again, this is part of the DBT scaffold, so it's pretty straightforward. You can see the models, the code, the compile code, description, column description, and one of the key features is viewing the lineage graph. So it gives you the upstream and downstream models impacted by this. This is pretty simple, so it looks easy, but there are cases where this looks very complex, and this lineage graph is extremely helpful in figuring out how your data is being built. So that's one of the most important features of DBT Cloud. You can do this without DBT Cloud. DBT generates artifacts like JSON and HTML. You'll have to store that in S3 or some cloud storage and host it, but DBT Cloud just does it all for you. So that's about it in this article. I hope this article gives you like a good understanding of how you could get started with DBT Cloud and Snowflake, and it can be any warehouse, honestly. DBT Cloud works with Snowflake, Redshift, and multiple other warehouses like BigQuery and such. There are more advanced features like customizing schema names across schemas, like you might have staging, UAT, staging 2 or whatever, and then using variables. You can use hooks to grant permissions to different roles after you build your models. So there are many more features, but this provides, I hope this provides like a starting point on your DBT journey. So to recap, we saw how we could set up Snowflake permissions to work for a DBT Cloud production environment and development environment, and also extend it to other environments as necessary. We saw how you could set up DBT Cloud and GitHub integrations and host your code on GitHub and run CI jobs on pull requests on GitHub repository. We also saw how you could schedule jobs easily using the DBT Cloud jobs section, and we also saw how you could host documentations that can be read by multiple users who have access to it. So the next time you're building a data stack, if your use case suits a ELT type pattern, I strongly recommend considering dbt Cloud and Snowflake. They make building ELT pipelines easier and simpler. You could set them up without dbt Cloud if you have an Airflow or Prefect or another workflow orchestrator. If you don't, dbt Cloud might be a good option for you. As always, please feel free to leave any questions or comment in the comment section below. Thank you for listening. Hope this was very helpful. And if it was, consider liking, subscribing, sharing, the YouTube stuff. Yeah, I'll see you everyone next time. Thank you.